I hope I can convince you of how important this is, and also because you're going to see it guaranteed almost every time we meet. Okay, so I said here, I know I'm trying to be funny. I'm not always funny, I know that, but I'm trying. I don't expect credit for that. But anyway, so first day agreement valid forever, because this is extremely important that I would like to set and agree with now moving forward. Every now and then you're going to hear one of your colleagues, or you may ask, where does the 2 come from? And I'm going to point out back to this. Okay? So why? Of course I will go back and show you why. It's not a problem. But I'm really hoping that once we understand this, moving forward, we're not going to discuss it again. Is it wrong to discuss it again? No, of course not. I ask a lot. I'm learning things myself, and I'm involved in a game, and I ask those experts. So a lot of questions. So, and sometimes more than once, right? So I know what you mean, and that's why I would like us to be prepared with this from the very beginning. So number one, I'd like to see what this is. First of all, I have to identify what that is. So I see here 2 terms. Last class I wrote 2019, so now I'm careful. I wrote 2020. Okay, so whenever we add 2 quantities, we are really looking at a binomial. And we know that, correct? Okay. So if we add or subtract, it doesn't have to be just adding, right? Adding or subtracting 2 quantities always gives us a binomial. Now, when I have to square a binomial, basically it's a plus b times a plus b. But we want to forget about this. Forget about foiling. We want to move forward. We want to step, move forward like a leap forward, not just a little step forward. So let's do this for now. I'm multiplying by distributing basically. So I get a squared, obviously, plus ab, plus another ab, and plus b squared. It is your responsibility to stop me if you have a question. It's your responsibility to say, I don't understand. It's your responsibility to say it's too fast. And I will listen. Is this okay so far? Yes. Everyone, yes? Okay, so obviously we are combining these 2. That's where the 2 is coming from. So I copy the first term, which is a squared, but I'm adding these 2, and I get 2ab and plus b squared. So every time you're going to ask, where does the 2 come from? Somebody or I will answer, from adding of 2 identical terms. That's where the 2 is coming from. Now, what is important here is to see the pattern. Nobody cares about a and b. What we care about is this. Any first term plus a second term squared. That's what I care about. Because I'm not going to be given a. I'm not going to be given b. I'm going to be given something like 2x squared plus 3y squared. So this becomes the first term, and this becomes the second term. This is what I'm going to be given. Or who knows what. Maybe even more difficult. So I have to understand the pattern. And then I will not forget how to address this. So what is the pattern here? It's the first term squared, plus in the middle, plus 2 times the first times the second, and then plus the second term squared. That's the pattern. I'm going to write it. First term squared plus twice times the first times the second. I meant to write ft times the second term, so ft first term, st second term, plus the second term squared. This is ft. Now, even if you want to forget this, if you say that, I don't know, 10 times in the next 2 weeks, you will not forget. So first term plus second term squared is first term squared plus 2 times the first times the second plus the second term squared. So I don't need to FOIL this anymore because I know that I have to square this, multiply the terms. 2x squared times 3y is 6x squared y times 2 plus the second term squared. Now, you can say stop because I don't remember how to square 2x squared, and I'll show. You can say stop, show me again how you multiplied and you got 12x squared y, and I will. You can say I still want to FOIL. Fine. No one will punish you for FOILing. However, when we get to complete the square, you'll have tremendous difficulties. When we get to factor, from here over there, you're going to have difficulties. So I don't recommend moving forward, continue to FOIL. These are special products. And basically, there are 5 different special products that we're going to look at. But these are the easiest ones. What do you think will happen if I have minus here and not plus?
Would it be the same thing?
Just the middle term will turn negative because now we are going to have 2 negative terms, identical but negative. Any questions? Any questions? Okay, so let's look at an example. Is it clear why when I square this I get that? This is a product. It's not a binomial. It's a product. So 2x squared, everything squared. I have to square the 2, and I have to square x squared. Copy the base, multiply the exponents. Any questions so far? So we have to draw a conclusion. We said that this was what again? A binomial. What is the answer? When we square a binomial, what is the answer? Excellent. Please remember, a binomial squared is a trinomial. Which means if I ask you how much is x minus 2 squared, you are not going to say x squared minus 4. Or plus 4 or whatever. Why? Why you will not say x squared minus 4 or plus 4? Because it's not a trinomial, first of all. That's not the only reason. It's not a trinomial, and secondly, it has to have plus 4, right? So you will say immediately x squared minus 4x plus 4. How come? First term squared minus 2 x times 2, that's 2x times 2 is 4x with minus, of course, plus the second term squared, which is plus 4. So let's put this on our handout then, our agreement. Although we are not signing it, I will hold on to it. I will hold you to it. So what will you say for the first one? What will you say for the second one? Excellent. Notice that the last term is always positive, no matter what. Now let's talk about the last one here. We're going to FOIL it now in order to draw a conclusion. And then remember it moving forward. So I FOIL. and then minus AB, and then plus AB, and then minus B squared. What happens now? Yes. So this is a nice one. Difference of squares. Please don't foil this anymore. So now I know if I have x plus 3 times x minus 3, what will I write with my eyes closed even? That's it. There is no need for these special products to continue to use FOIL. For others, yes, of course. But for these three, no. So then what do I write for the last one? So in general then, this really means first term plus second term, first term minus second term, for any terms. What will that equal to? In short, that we should remember moving forward. First, oops, that doesn't work. So if we establish this moving forward, we're going to be happy. So let me give you an example, or maybe another example here. Let's say 2x minus 3y. And what should the other one be for this formula to work, for this special product to be applicable even? Very good. So then the answer would be? That's it. Any questions? Any questions on this? Are we okay? I would like to go back to that factoring document, the one before this one, that I said I should have put it together. So here's what I would like to talk about first. Okay. We can be given to factor 3 possible polynomials. One that is called the other one that is called and anything that is not a binomial or a trinomial. Anything else. Okay. From these three, the most difficult one is in the middle. Why is this the most difficult one? Is this a formula or a special product that we just looked at? Where does this come from? What is this? A minus b, everything squared. What about, because now we know the pattern. So it's much easier when I look at it, I know it's a minus b squared. Where does this come from? Right. Good. Now this is totally different. We have to discuss those. But here, we already discussed the first one. How do I factor this one? Going backwards. How do I factor this? Times? Excellent. So these have an immediate application. And you can say, okay, wait a minute. So what is this factoring all about? Why do we need it? For a lot of reasons. Solving quadratic equations, solving rational equations, and way more than that, not just the two. So applications that I gave you as example. So now what is the strategy? So first of all, whatever polynomial you give me to factor, I will arrange it in descending order based on the powers of the variable. That will always be the first step, no matter what polynomial you give me. It could be a binomial, trinomial, whatever. First, I make sure that it's in descending order of the powers of the variable. That's the first step. What do I do next? I make sure these two are interchangeable in order if you want, or these two can be in one step, these two. So if I see a greatest common factor to all terms, whatever binomial I have, I pull it out. And if the leading coefficient is negative, I pull that out too. So these two can be in one step. What do I do next? Then I look. And I'll say, okay, what is it? Is it a binomial? Then I have this strategy. Is it a trinomial? Then I have this strategy. If it's none of the above, then it's this, and then I have a different strategy, which is just very simple. Factoring by grouping. I don't have anything else. There are some other sophisticated ways, but we don't need to go beyond what we learned in this class. Okay? So let's go to this handout now. I know I only have 4 minutes left. I'll just try a couple of examples. We would not have to do everything. So in the video, I had the same document. Sometimes I do a lot of them. Sometimes students know what we're talking about, and so please look at what I covered last time. But please choose from here. Do not choose a difference of cubes and a sum of cubes. I cannot show you in 3 minutes those two. So choose anything else. In other words, you cannot choose C and you cannot choose E. Not at this point. Till you look at the video and then we practice with the sum and difference of cubes. So which one would you like to choose? Or I can make one up. Okay, so we want 4z squared minus 25. Oops. How many? Good. So for z squared minus 25, I have to go, and I always go through the entire strategy. What type of polynomial is it? Yes, it's a binomial. Is it in descending order? Greatest common factor. If you skip any of these steps, you're making it more difficult on yourself. So descending order, yes, it's a binomial. Descending order, yes. Greatest common factor, no. 4 and 25 don't have a common factor. Is the leading coefficient negative? No. So then I can go directly and choose. Okay, what am I choosing? I can choose this. We haven't discussed it yet. I can choose this. I cannot choose the plus because it doesn't have plus. I have to choose the minus. So if I choose that minus, which is the difference of squares, then I know exactly what to write because we just discussed it. And what do I write? Yes. Minus. Plus or minus, it doesn't matter, but the other one has to be opposite. Yeah. 2z plus 5, 2z minus 5, and yes, you can write it as 2z minus 5 times 2z plus 5, of course. Same thing. Okay, we have 1 minute. Let's choose one more, and then we'll stop.
We do B, please.
B, perfect. So x to the fourth minus 81. Please remember that every time we're asked to factor, we have to factor completely. Till factors cannot be further factored. Again, in descending order, yes, it's a binomial. Greatest common factor, no. Negative leading coefficient, no. Special product, I hope. So we haven't discussed anything else but the difference of squares. So that's why we chose it. How will you factor this?
X squared plus 9.
Yes.
X squared minus 9.
This is, we will talk about it. Well, you'll see it in the video. Not factorable. This is not the entire story. I'm not telling you the truth. I should write it's not factorable using integers. It is factorable, but we don't care to factor it right now because we cannot use integers to factor it. But x squared minus 9 is factorable. So I copy x squared plus 9 because it's not factorable, but I will factor x squared minus 9. How? Anyone? That's it.